the data set that I run using Oracle Data Miner for the car sales. In my earlier video, I'm going to use the same data set, but I'm going to run it in Python code. So this is my Jupyter notebook, which I'm running from Anaconda. So the first step will be importing pandas and importing linear regression function. I'll read the car sales file as a CSV file, verify the first 5 rows here, compute some statistics for all the numerical columns so I can verify that what are the values mean, median, standard deviation, all. Then I will compute a regression where the target variable, the dependent variable is price, and the independent ones, the determinants are year, mileage, and miles per gallon. Plot the intercept and print the coefficients. So I will see what are the coefficients for year, mileage, and mile per gallon to predict price, and how good this model is for these three independent variables. That is where I will get R square. Then I will filter saying there are 23 different models of the cars. Let me filter for model A1 only. So my model is only A1. I print the first 5 rows to verify that I am capturing only A1. I'm going to recompute linear regression for price, but computed based on year and miles per gallon only. Okay, I'll ignore mileage for the present. I'll just say how old the car is and what miles per gallon it gives. Then I'll print the coefficients for those two determinants, year and miles per gallon, and how good the R square is, how good this model is. So I'm going to run through all of it in one shot. So let me just scroll back to the top. So this is where I've read the car sales CSV file, printed the first 5 rows. I know I can see there are multiple rows. I do a describe. There are 10,668 rows, all because the car ID is unique. For the price, the mean price is 22,896. The standard deviation is 11,714. The first quartile is 15,130. The third quartile is 27,990. And the median is 20,200, while the mean is 22,896. So I have similar statistics for all the numerical variables. Then I compute linear regression. My dependent variable is price. I'm using year, mileage, and miles per gallon to predict. So the coefficients for year, mileage, mile per gallon are these. Okay, so that's year, mileage, and miles per gallon. The higher the miles per gallon, the lower the price. So that's minus 3.99. The higher the mileage, that is, the longer the car is run, the lower the price. So that also is a negative coefficient. While the year, the newer the car, the higher the price. So that's why year has a higher coefficient. But if I compute the R square, it's not a very good fit. It's only 0.52. So these three predictors are not very good predictors for the price. Now I'm just going to start filtering only for car model A1. So this is where I do the filtering for car model A1. Create a new data frame called DF model A1. Verify that I have only A1 here in my new data frame. And then I compute a new regression model for year and miles per gallon to predict price. So if I print the coefficients, this time I'm just going to ignore the intercept. I just print the coefficients for year and miles per gallon. So again, miles per gallon is negative. The higher the mileage, the higher the miles per gallon, the lower the price. The newer the year of the car, the higher the price. So the year is positive, miles per gallon is negative. And what is my R square to see how good it is for the this model of year and miles per gallon predicting price is 0.82. So this R square is good. So this model year and miles per gallon to predict price for car model A1 is quite good. 0.82 is the R square.